Hello. So let us start from linear and nonlinear differential equation. As you know, I've already discussed about the order and then differential order and the degree of the equation. So, but for today, we are moving into linear and nonlinear differential equation. First of all, I've already told you that if you are given this kind of particular equation, which is given as the y all over the x plus 2y minus x squared. So this equation, for you to firstly believe either it is linear, or let me firstly say, for you to believe it is differential equation, it involves a dependent variable, which is this y, and also it is involved its derivative, which is this dy dx. So for the order of the differential equation, you just have to check which one they differentiated most. So here now, the y dx can simply refers to what? Can simply refers to y prime, which is telling you that they differentiated this dependent variable y how many times? Only one time. So that one time is what you are going to know as the order. And then for the order, you have to check this derivative. It is raised to power what? It is raised to power 1. As you can see it here, I can write this thing as a bracket close, all to the power of 2. I can gently write this thing like this. It is still this. So if I write it like this, all to the power of 1. So what we are having here now is still the same thing as what we are having before. Anything raised to power 1 is itself. So this derivative was differentiated only once, and then it is raised to power 1. This once that they differentiated it is what you are going to denote as your order. This all it raised to power is what you are going to denote as your degree, which is 1. So for the linear, in such way, you just have to check the given equation. Here you are having y, and then this y is raised to power what? Is raised to power 1. Meanwhile, it is going to be linear. The idea is very simple. Let's say you are having something like y is equals to mx plus c. So this is what you can call as a linear equation. Like for instance, you can compare it with this one. If you are having something like x all to the power of 2 and then plus 2x and then minus 6 equals to 0. So this kind of equation is what you can refer to polynomial equation, because it has the degree of 2. So here the degree that we are having here is what? Is 1. I can write this one like this. So we are having x to the power of 1 is still the same thing as x. Here that we are having x to the power of 2, the degree of this kind of particular equation will be what? Will be 2. But for here we are having 1. So here that we are having all raised to power 1, our degree will be equals to 1. Meanwhile, it makes the equation to be linear. So if you want to name this one like this, you are going to write it as a first order, and then first degree, and then linear differential equation. That is for the first question. Let us quickly move to the next question, which is question number 2. Here we are having the square y all over the x square. We are given the square y all over the x square plus 3 dy all over the x all to the power of 3. plus y equals to 0. They ask you to determine your order, also your degree, and also either it is linear or non-linear equation. So first of all, as I've already told you, I said once you are given the equation, firstly check which one they differentiated most. Here you are having the square y all over the x square. It is telling you that we are having y prime prime. They differentiated y how many times? 2 times. So the next thing that we are having is what? We are having the y all over the x. We are having only y prime. They differentiated y only 1 time. So the one that they differentiated most is what? Is this y prime prime, which is 2. They differentiated it how many times? 2 times. So this 2 is what we are going to denote as our order. So for the degree, you will now go for the highest differential coefficient, which is this highest one. This is the highest differential coefficient. This one, they just differentiated it once. It is not higher than this one. So this one is going to be the highest, and this one will be lower than this one. So you just have to check this highest one and check it is raised to power what? Anything that you are seeing on its own. If you are given x, if I ask you x is raised to power what, you can gently tell me that x is equals to x to the power of 1. You can gently say x to the power of 1. Sorry. Because anything raised to power 1 is still itself. So here that you are having this kind of particular differential coefficient, you can say it is something like this. You can call it as something like this. Bracket open. Also, you can put bracket close over here. Bracket close. You can now say that all to the power of 1. All to the power of 1, because anything to the power of 1 is itself. The square y all over the x square to the power of 1 is still itself. So our degree is going to be equals to 1. The idea you have to denote for this one is that once your degree is equals to 1, you can gently discover what either it is going to be linear or non-linear. So here is the idea. Once you are having your degree equals to 1, it is going to be linear. Once it is greater than 1, either to the power of 2, to the power of 3, etc., it is going to be non-linear. So if you want to name this kind of particular equation, you are going to say second order. You are going to say you are having something like a second order, comma, first degree, comma, linear differential equation. So that is for the second question. Let us quickly move to the third one. Here you are having something like the cube y all over the x cube plus 3 brackets open the square y all over the x square all to the power of 2 equals to sine x. So we want to determine your order, also your degree, also either it is linear or non-linear. If you check this kind of particular equation, you are having the cube y. Meanwhile, here the idea is you are having something like this, y prime prime prime. They differentiated y 3 times. Also, the next thing that we are having is what? We are having y prime prime, because for this one they just differentiated y 2 times. So which one is the highest one? You could see that this prime prime is not greater than this prime prime prime. So this one that they differentiated 3 times is what we are going to denote as our highest coefficient, highest differential coefficient. And then how many times they differentiated it? It is 3 times. That 3 is now going to be our order. For the degree, you just have to go back to where you get your highest differential coefficient and check it is raised to power what. This one I've already told you that you can say it is raised to power 1 since they did not put any power, and then anything raised to power 1 is still itself. That's the reason why they can just write it like this. Meanwhile, your degree is going to be equals to 1. Since our degree equals to 1, it is going to be what? It is going to be linear. So the name of this kind particular equation is going to be what? Is going to be third order, comma, first degree, comma, linear differential equation. So that is for the third question. Let us move to the fourth one. This fourth one is somehow tough, but it is very simple if you can understand the logic. Here you are having the y all over the x all to be equals to the big square root of 1 plus bracket open the y dx all to the power of 2. The concept is that I've already told you, if you are having something like a square root can also be transformed to what? To 1 all over 2. That's the reason why I used to say that. Let's say you are having something like this, you are having square root like this, and then what you are having inside is x. You are having x, square root of x. So what you just have to know here is that if you are having something like this, it is equals to x to the power of 1 all over 2. You just have to transform this square root into power of 1 all over 2. So anything to the power of 1 all over 2 mean square root of that kind particular thing. So that's the thing that you are going to do here. All what you are having inside the square root is 1 plus bracket open the y, the x, all to the power of 2. So you just have to transform the square root into power, and then it is going to be equals to what? It is going to be power of 1 all over 2. And already here we are having square root of we are having to the power of 2. Power of the power. If you are having something like bracket open x to the power of 2 bracket close, and then to the power of 2 again. So here you can see that you are having power of the power, x raised to power 2. Also everything now later raised to power 2 again. All of them equals to, the idea is this, just multiply all the power. You are having the first power to be 2, the second power to be 2, which is going to give you what? It is going to give you 2 times 2, x to the power of 2 times 2, which your final answer will become what? It is going to become x to the power of 4. So here that we are having something like x to the power of 2, here that we are having something like x to the power of 2 is equal all to the power of, we are having x to the power of 2 and then everything to the power of 1 all over 2, and then equating it to be equals to, you just have to say that x to the power of 2 multiplied by 1 all over 2. 2 multiplied by 1 all over 2 is going to give you what? It's like you are having half of something. Let's say you are seeking for 100 naira. If you have 50 naira multiplied by 2 is going to give you what? It's going to give you 100. So exactly like this one also, if you are looking for 1, just take half and use it to multiply 2. Or let me say something like this, if you are having let us use the fractional form to make everything clear. Let's say you are having something. Let's say if you are having 1 all over 2 and then multiply by multiply by 2. So here like this, what you just have to do is this. You just have to say this 2 is going to cancel out this other 2, because once you multiply them, you are going to have these two multiplied by this one, which is going to give you 2 all over 2, and 2 divided by 2 is equals to what? Is equals to 1. Definitely your final answer here will become what? Will become x to the power of 1, and then anything to the power of 1 is still itself. So this is where we came from. Here that you are having this big square root, we now transform the big square root into this power 1 all over 2. If you now multiply this 2 by this 1 all over 2, this 2 is going to cancel out this 2, so you are going to left with power of 1, and then your order is to check through all the derivative, which one is the highest differential coefficient. You can see that they just differentiated everything once. This one is y prime, this one also is y prime. Meanwhile, our order will be equals to 1. They differentiated them once, and then since both of them equals to 1, they differentiated both of them once. Which one has the highest power? Here, don't forget, we just left with the power of 1. Here also, we can say that it is raised to power 1, because anything raised to power 1 is still itself. That is to say, our degree is still going to be equals to 2, to be equals to 1. Since our degree equals to 1, definitely it is not a polynomial equation. It is going to be what? It is going to be linear equation. And then if you now want to name this kind particular equation, what you are going to write is what? Since our order equals to 1, you are going to say first order, comma, and then first degree, comma, linear differential equation. That's the name to the equation. Let us go to the next one. Here is the last question that I'm going to solve. So, and then I've already dropped 10 examples, so make sure you go through everything one by one, and then you can ask if there is any question. So this question number 5 here, we are having the cube y all over the x square plus the square y all over the x square, all to the power of 3, plus the y all over the x equals to 1. A is what you just have to firstly take note. This first derivative, which is the cube y, it is telling you that you are having what? You are having y. It is telling you that you are having y prime, because they differentiated y how many times? 3 times. For this second one, you are having what? You are having y prime, because they differentiated y 2 times. For this third one, you are having y prime. They differentiated y 3 times. Which one they differentiated most? Which one is the highest differential coefficient? You can see that this one that they differentiated 3 times is what is going to be the highest one. So how many times they differentiated it? 3 times. It is going to be your order. For the degree, you just have to check this, the cube y all over the x cube. It is raised to power what? Definitely it is raised to power 1, because anything raised to power 1 is still itself. Don't be mistake of taking this theory instead, because this, the square y all over the x square, is not the highest differential coefficient. So this is where you are going to get your degree, not in this one. So the power that we are having here is what? Is 1. So, and then since the power is equals to 1, it is gently going to be what? It is gently going to be linear differential coefficient, because if you now want to name this kind of particular equation, you just have to say third order, comma, first degree, comma, linear differential equation. So that is the way you are going to name the particular equation. So let me quickly brief everything from the beginning once again. For this first one that you are given this kind of particular equation, as you can see, we found that our order is equal to what? Our order is 1, and also our degree is 1 as well, and also it is linear equation since our degree equals to 1, and the name we give to it is first order, first degree linear differential equation. For the second one, we are given the square y all over the x squared to the power of 1, all this blah 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 blah, so plus y equals to 0. You can see that our order that we found here, because the highest differential coefficient is the square y, so they differentiated it 2 times, and degree, it is raised to power what? Raised to power 1. Since it is 1, we are going to have it as linear equation, so we name it as second order first degree linear differential equation. So for the third one, you are given this question. You could see that they differentiated this one 3 times, they differentiated this one 2 times. This is going to be the highest differential coefficient, so we took our order to be equals to 3, and then this highest differential coefficient, it is raised to power what? It is raised to power 1, because if you can check this thing well, you can see that it is raised to power 1, so that one is going to be our degree. Since it is, we are having the degree to be equals to 1, definitely going to be linear equation, so the name given to the equation now become third order first degree linear differential equation. So for the fourth question that we are having this one, the idea is just to take note that wherever you are having square roots of something, is same thing as that particular stuff inside the square root 10 to the power of 1. That is the reason why I gave this thing as an example. X to the power, the square root of x is same thing as x to the power of 1 all over 2. So we now transform this square root to the power and put it on top of this current square current power, which is 2. We now have power of 2 all to the power of 1 all over 2, as we are seeing it over here. So since we are having something like this, we now say that 2 multiplied by half is going to give you 1. So, and anything raised to power 1 is itself. So the differential coefficient that you are having here is just dy dx dy dx. That is the reason why our order equals to be 1, and then all of them are raised to power of 1, because here we have already solved out everything and we got 1. Here also the power of this one is 1. Our degree equals to 1. Since our degree equals to 1, definitely it is going to be linear differential equation. So we now name the equation to be equals to first degree, first order, first degree differential, first order, first degree linear differential equation. And then here is the last one. You are having the cube y all over the x cube, which it has been differentiated 3 times. The square y all over the x square, it has been differentiated 3 times. And also the y dx, it has been differentiated once. So the highest differential coefficient here is this big one, which is it has been differentiated 3 times. That 3 is now going to be denoted as our order. and then you now have to come and check this differential coefficient. It is raised to power what, which is raised to power 1. That one is now going to be our degree. Once your degree equals to 1, the equation is going to be linear. But if your degree is greater than 1, your equation is now going to be non-linear differential equation. So the name we give to this kind particular equation is a third order first degree linear differential equation. That is that about the linear and non-linear differential equation. I think now we have covered what order of differential equation mean, and also the degree of the differential equation, and also the linear and non-linear differential equation. Now the only thing remain now to know is homogeneity, which is rather going to be either the equation is homogeneous or non-homogeneous differential equation. So make sure you go through everything and solve the left question awarded to you.